Hello, it's Keith here, and this is lesson 19 of the simple series of my Z80 programming tutorials. And in the simple series we make simple examples that are all one contained file to do a single job. And today the job we're going to be doing is working on the Game Boy. You can see an emulator up there, and we're going to be putting a single tile on the screen, and we're going to be able to move that around the screen with some range checking. So you can see here we've got this smiley and we're moving it around the screen, but it can go off the screen. This example will work on the Game Boy or the Game Boy Color. It's one example for both systems. So hopefully this is a nice little starter. If you're looking to build your own game and you need to get started, it'll get you some graphics on the screen, some input, and you'll be able to hopefully build on this and make something far better. So that's the plan. Now the Joypad is the new thing. The rest is based on the simple series bitmap example, but we're going to have a quick look at that, but primarily we'll focus on the joystick routines. So the joystick on the Game Boy works in the following way, the Joypad I should say. Basically the directions and the buttons are split into two sections, and we first select which of those two we want to read from, and we select the part and read the data using the memory map port FF00. So we will write to this port with a bit set to 0, and if we set bit 4 to 0 we will be reading directions, and if we set bit 5 to 0 we will be reading buttons, and then we read back from that port FF00, and the bottom 4 bits will either be right, left, up and down, or the 4 fire buttons. So that's what we do, and we'll see that in our code. Now, as always, you can go to my website and download the code, and I strongly encourage you to do that. And you can use it in your own games and things if you manage to do so. You don't need to worry about doing that. It's all free, open source. You can do whatever the heck you want with it. Now, we'll go over the code and we'll discuss what's going on. We will go over very quickly the bits that haven't really changed. So the first thing we're doing here is we're defining 4 bytes of memory. Now, these are an X and Y coordinate for the current position of the sprite and a backup version for the last position. I'm saying sprite here, I should really say tile map. We're using a single tile of the tile map. We're not using a hardware sprite in this example, but using the tile map is easier if you're a beginner. It limits you to 8x8 block movement, but you don't have on sprite limit count limits and things, so I think it's going to be better if you're just getting started to just limit yourself to using the tile map, because there's been lots of great simple games that have been done using the tile map. It should be enough to get you started. Now we've got our cartridge header here, lots of stuff here, loads of returns for interrupts and things, and we've also got the Nintendo logo there. It is required for an official cartridge, and some other header parts here. I'm not going to go into them. You can go and download them from my website. And then we've got the initialization for our cartridge here. We're just initializing the stack pointer, setting up the tile map scroll position, and then we're just waiting till the screen is turned off. We're then defining some tiles using the define tiles routine we used last time. Now, I'm not going to cover that because, as I say, that's covered in the simple series. But we will just discuss the tiles that we're actually defining. So we've got two. First, we've got our smiley. There are 2 bit planes here, so you can see the first one defines the sort of body of the smiley, and the second one defines the mouth and the eyes. And then we've got a blank one, which is just all 0 bytes here, and that is going to be used to remove the smiley from the screen. So we've got those 2 that we're going to be using. Now, when our program starts, the first thing we're doing is we are zeroing the X and Y position of the sprite, which will define it starting in the top corner of the screen. We're then skipping over the next section, which would wait for the keys to be pressed. So we're skipping over that so that we see the initial position of the sprite. Now, when we want to read in from the Joypad, what we're doing is we are setting bit 4 to a 0. That defines that we're reading in from the directions, and we write that to FF00. That selects that we're going to read the directions. We would set this bit here if we wanted to read the fire buttons. We then read in from the same port, FF00, and we're just setting the top 4 bits to 1 because they aren't actually used in this example, and that means we can just make this more consistent with our other examples. We see if any of the directions are pressed, and until they are, we just skip back up here. We just repeat until a direction is pressed. When a direction is pressed, like this, we will work on it, and that's when this start draw routine will kick into action. So what we're doing here is we're backing up the current position of the player. We're then removing the old player from the screen. The way we do that is very simple. We've got this routine here called draw player, which shows tile 128, which is our smiley to the screen. We're using get VDP screen pos to calculate the VRAM address, and then we're writing that tile 128 to the screen. We're also setting the colors for the Game Boy Color. That's the only part of the code that's really Game Boy Color exclusive here. Now 128 is the smiley, and 129 is the blank sprite that we defined before. So there's our smiley. So there's our smiley, and there's our blank sprite there. So that's why we're using 128 and 129. That if we wanted to use different ones, we'd need to change the address we transferred the sprite to. This was defined up here. So that's why we're ending up with the tiles 128 for the smiley and 129 for the blank. Now, once we've removed the old position from the screen, we're now going to calculate the new position. So what we're doing is we're testing each of the direction bits. If the direction isn't pressed, in this case up, we're skipping down to here. But if it is, then we're actually decreasing the Y position. In this case, here we're increasing the Y position. Here we're decreasing the X position. Here we're increasing the X position. So we're changing the directions accordingly. Now, what we're doing next is we're checking the boundaries. So we're checking the X and Y position to see if we've gone off the screen. Now, if we've gone off the right-hand side of the screen, for example, the X position will now be above 18. But because the left-hand side of the screen is 0, and if we go back below 0, the register will wrap back to 255, we're actually effectively checking both the left and right-hand side in one go here. If the player's gone over any of the sides of the screen, we're using this player reset function to reset their position, and we're using those backup copies of the XY position to reset the player position. And that's why if I go over to my code here, my example here, and if I just keep pressing right, I'm holding down right, I ain't moving. That's because we're limiting that position there. So once we get down to here, we've updated our player position accordingly, depending on any changes to the direction, and we now show the new position of the player, and then we've just got a simple dumb loop there to delay for a while, and then we jump back up to the top here, and we repeat again for the next iteration of the code, and that's really all there is to it. It's a very simple little example, and that's the point of it. As I say, you can go to my website, you can download this example, and hopefully you can have some fun with it, and maybe you can make something interesting of it. The idea is that this is a simple example that should get you started with some graphics and some movement, and then hopefully your imagination can take this into a little game. Anyway, go to my website, download the source code and the build scripts. If you want to support my channel, you can buy my book. It's called Learn Multi-Platform Assembly with Chibi Akumas, and it covers Z80, 6502, 68000, 8086 and ARM, and of course Z80 is very similar to the GB Z80, the Game Boy, so maybe that'll be interesting to you. As I say, it's a great way for you to get something hopefully useful to you, and it does support my channel. Anyway, I hope you've enjoyed this. Thanks for watching today, and goodbye.